Okay, here are a couple popular questions that come up with this worksheet. First question is, how do you know which way to make positive? Some of the free fall problems you made up positive and some of them you made down positive. Here's my recommendation and why. Always make the weight is moving the positive direction. The consequence of that is if it's experiencing acceleration, it'll make it easier for you. Remember when we were studying acceleration, I said positive acceleration does not always mean speeding up, and negative acceleration does not always mean slowing down. If you make the positive direction the way it's moving, then you can make that claim, saying if it's going in the positive direction and it's speeding up, then that's positive acceleration, and if you're going in the positive direction and you're slowing down, then that's negative acceleration. So it's a kind of a physics hack to make the way it's moving positive. Good with that? Okay. Another popular question is, how do I know when to tilt the axis and when not to? So let's say you have this scenario. You're dragging a box. Yes, that tension is at an angle, but you're not tilting the axis. The surface that it's on is horizontal, so you're not going to tilt the axis. You will tilt the axis when you are on a ramp or an incline. Okay. Now, when you're drawing your free body diagram, you're going to tilt your axis where the x-axis is going to be parallel to the ramp and y is going to be perpendicular. So when you draw your free body diagram, it looks like that. Okay. Whatever that angle is, that is the same angle between that and the new y-axis. Okay. Not that angle. Okay. That is a popular error there. So it's the blue angle, not the red. Okay. When you're doing this, that's your y component of the force of gravity. Is the x component FGX there, or is it the dark green or the light green? Is FGX the light green or the dark green? Tell your neighbor what the correct answer is and why the wrong answer is wrong. Which one's correct? Dark green. Okay. Drawing the light green is a popular error. I actually did this when I was in your shoes. I did the light green, lots of points. Here's why light green. probably the most obvious reason, you want your x-axis is now going this way. You want your x component to be in that same direction. A second reason, this is kind of just a consequence, in our triangle with using the light green, which side is the longest side? The blue, the red, or the light green? The red would be the longest side, which would be stupid. So that's supposed to be a component of this. This needs to be the hypotenuse. This needs to be the longest side. So make sure you don't have that same error that I did. Okay. Now, some people, this messes with you, like this tilting of the axis. If if you're finding this is like wacky for you, here's my recommendation. Draw the free body diagram. And then once you have drawn that, then literally, like physically take your paper and twist it so the axes are like what you would normally expect. Your force of gravity is going to be doing this, friction, normal force, and this would be your theta, and then you can draw your FGX and your FGY. Okay. So that's, if you're like, this messes with me, just literally take your paper and physically rotate it. So it looks like what you're used to looking at. Good? Okay, so you've got a worksheet over this stuff due tomorrow. Okay? If you can own the setup, incorporating numbers should be easy. If you don't do the setup, it's going to be a little rough. And it'll get rougher as the day goes on, or the days go on. Okay? All right. Give that one a shot. Have a conversation. Correct answer is B. Good job. Acceleration is the ratio of force to mass. Good with that? The same ratio of force to mass. This is a very ridiculous scenario, but just go with it. Tell your neighbor. Correct answer is C. Okay, you have a huge weight and you have an equally huge normal force, but your applied force is like infinitesimally small comparatively. But even if you have a really small force and you have a really big mass, will acceleration ever be zero? You can never have enough inertia to cancel out a force. Okay? This gets closer and closer to zero, it gets smaller and smaller as the mass gets bigger, but never will you make that zero. You all right with that? Okay. So mass does not cancel out force. Thumbs up when you have a guess. Okay, before you have a conversation, check out this follow-up question. Same scenario, but a different question. You see the difference between the two questions? Okay, have a conversation. This is the first question.
The force is going to be running at the same height. They're going to land it. They're going to accelerate it. It's not counting for air. No, because the mass. The force by the mass. Right now, just say as the first word A as in accelerate or accelerate slower. It doesn't matter. Overcomplicated. The point is just cover it right. Cover it.
Well, I'm telling you that it's not. The acceleration is
If you get some vacuum chamber and drop on center and try at the same time, they're going to accelerate at the same rate regardless. Okay.
Okay. What is the answer to this question? What is the answer to this question?
That one is A. That is A.
This one is A.
This is A.
Okay.
It's A.
What is another name for force of gravity? Weight. Do they have the same weight? Okay. So here, this one has a greater 10 times amount of weight as this. You all right with that? If we're doing the setup, we'd say some of the forces in the y direction are not equal to 0. I'm going to make down the positive direction. So I have force of gravity is equal to mass times acceleration. That's for both the brick, the setup for the brick and the book. So when I find acceleration, it's the ratio of force to mass. This is identical for the book and the brick of 9.8 meters per second squared downward. Because, so the acceleration of gravity is the same. The force of gravity is 10 times greater for the brick because it weighs 10 times as much, because it has 10 times as much mass. Okay? So here's the deal. As on or near the surface of the earth, as the mass increases, so does the weight. Everybody okay with that statement? As you get more massive, it gets heavier. Okay? And in free fall, you have more force pulling you downward on the brick, but it has also more inertia saying, I don't want to do that. Versus the book, it does have force gravity, but not as much, but it also doesn't have as much inertia saying, I don't want to do that. And so, like, that ratio of force to mass is identical. Therefore, all of them fall at the same rate. That is why all things fall at the same rate, 9.8 meters per second squared, on or near the surface of the earth. You good with that? Okay. If you did not listen to the video, you might want to do that. But this equation is a conversion between newtons and kilograms. Okay? If you're trying to go between weight and mass, this is the equation you use. Okay? This is a conversion factor where G is equal to the absolute value of the acceleration of gravity. You do not need to be in free fall to use that equation. It's just anytime you're on or near the surface of the earth, you can use that equation is valid to convert between mass and weight, kilograms and newtons. Okay? In class, to make this life a little easier, we're going to round that to 10 to make mental math easier. Okay? But you're going to use 9.8 on homework, on labs, and on tests. But for these multiple choice questions here, you can round that to 10. Okay? My recommendation to answer this question is set it up. Don't do numbers. Don't incorporate numbers until you've set it up. Good? Tell your neighbor.
She's wrong that. That's wrong. Why would you do How do you get? I wouldn't enforce it. I don't know. Okay. Like 10 is 5. But then there's 2 grams. We're not learning sign language.
There's your setup. That makes sense? Okay. Can I stick in 50? Some of the force in the Y direction. Just vertically. Can I stick in 50 into here? What is this? This is mass. How do I convert between mass, kilograms, to newtons, force of gravity? Okay. So this is equal to 50 kilograms times, we're going to say 10 equals 500. We're going to assume these two are the same force of tension. So you have twice the force of tension is equal to 500 newtons. So force of tension equal to 250 newtons. Okay. You see why doing the setup is important. Okay. Learn some stuff. Incorporate it in this one. Make sure you set it up. Thumbs up when you have a guess. My hypothesis is if you didn't set it up, you're going to miss it. Have a conversation.
The force of gravity should right now, but and put that in. What? What?
What did you get? I had an answer. See, I thought it was easy. But like, accelerated.
It's gonna be oh my gosh, we did get it wrong. No, we didn't. We're good. For sure. Wait.
Okay, so yeah, 15,000. Can I stick in 500 in for force of gravity? No. I use this equation. 500 times 10, that gives me 5,000, is equal to mass, kilograms, 500 times acceleration. So I end up with 10,000 divided by 500. Okay. Folks, if you just jump to the numbers, most of you would get it wrong when you said E. So, like, check it out. I've got a force. I've got a mass. I'm looking for acceleration. Dude, I know that force is equal to mass times acceleration. Boom, boom. Got it. Okay. What you did was you found the acceleration if your elevator is in deep outer space and there is no force of gravity. Seems highly unlikely. Does that make sense? Like, you assume that all your problems that we're going to do in this class are on or near the surface of the Earth. Gravity is a thing. Okay? Do not just take numbers and do math. Do the setup. Okay? Thumbs up when you have a guess. Have a conversation. Tell them how you got there.
You know the mass. Is new. Mass and grams or accelerated? You're going to cut off force of gravity. Right?
Move. All of them are good.
Wait, no, 4 million.
Wait, no, sorry.
I think it's deep.
Of all of those numbers. Maybe
I think it's deep.
But that's not. I don't know what it is.
What did you get? What did you got? I can stop.
There's your setup. If you answered C, you didn't do the setup. Okay? So, can I stick 100,000 in for force of gravity? No. And use this. Are we seeing a theme here? Okay. Okay, so that's going to equal 1 million. Your mass is 100,000 times 30. So that's going to give you 3 million. And you have 1 million on this side. We can bring that over. You have 4 million. We're so we're going to say boosters collectively. If it was just like for each booster, I'd give it to you.
I was trying to make it right.
Okay. Folks, do not just take numbers and do math. You must set it up. Okay, got a worksheet due tomorrow.